say, there it is, I can demonstrate the law of conservation of mass using balancing chemical equation. I would recommend that you copy your I can statement so you have that as your focus going throughout the class. Alright? Has anybody ever heard about the law of conservation of mass? Anybody? Yes, what do you know? Don't be shy.
Oh, that mass always stays the same.
Very good. Say that again for the rest of your classmates.
Mass always stays.
Mass always stays the same when you have a chemical reaction. Alright? So the same thing that you start with is the same thing that you will end with. Okay? Quickly take a seat for me, please. I've already begun. Whatever you start with in a chemical equation or a chemical reaction is what you will end with. It's called the law of conservation of mass or the law of conservation of matter. Now I have a question for you. What do you think would happen if I react water with baking soda versus vinegar with baking soda? Make a prediction. Water with baking soda versus vinegar with baking soda.
Vinegar and baking soda.
What about the second one? What do you think will happen with these two?
Yeah.
Alright, so you think there will be a chemical reaction? What about water and baking soda? It will like mix. Alright, so let's try that. I'm going to ask for your assistant. What's the name? You're going to be doing baking soda with water. So you're going to be mixing that. Show your classmates what happens when you mix baking soda with water. Will there be a chemical reaction? Stir it for me so they can observe what happens. Is it reacting? How does it feel? Like room temperature? So there's no change in temperature, right? Now, it's simply, thank you very much for your assistance. It's simply, it is foggy, right? But what happens is that it simply dissolves, okay? To form, I'm not going to be competing with you. So if you're talking while I'm talking, I'll stop and wait on you. So if you dissolve baking soda in water, it simply forms what we call a solution. You've heard that before, right? So you have your solute and you have your solvent. If you put the two together, you form what we call a solution. Today's class is based on chemical reaction. So we are going to combine baking soda in an open container with vinegar. Let's see what happens. What do you think will happen? It will start giving off gas bubbles, which would suggest that there's a chemical reaction taking place. Alright? You're changing one or two substances to make something different. Okay, so let's look what happens. Alright? So baking soda and vinegar react to form a gas. Anybody knows what gas that is?
Carbon.
Carbon dioxide. Alright? So there are two products that are made at the end of this reaction. Carbon dioxide and also water. Okay? So your chemical reaction involves changing reactants into products. Alright, you're forming something new. Now what you start with is always what you end with, unless a gas escapes. So if I had done the same reaction in this bottle that had a lid on it, do you think the gas would escape? No. So the likelihood of us having the same amount that we started with and ending with the same amount is more likely in this container, right? So this is what we call a closed system. The law of conservation happens in closed system. What you start with is what you end with. The reactants must equal to the products. Your reactants are what you start with. Baking soda plus vinegar gives you carbon dioxide and water. Products, reactants. What you start with are your reactants. What you end up with is called your, somebody give me the word, the product. Okay? Alright, let's move into watching a short video, and then we will take short notes on the law of conservation of mass. Alright? So while the video is playing, you're going to give your undivided attention to the front of the room, and I'll pause every now and again to check your understanding of what you're watching. Okay? So let's turn this up from the get-go. Is everybody ready? Okay. Law of conservation of mass.
What is the conservation of matter? Believe it or not,
Remember we said the law of conservation of mass is the same thing as the law of conservation of matter. So if you see both of them, it means the same. Good?
an important scientific law behind these delicious cookies. It is the law of conservation of matter. This law states that during a chemical reaction, matter is neither created nor destroyed. The total mass of the reactants must equal the mass of the products.
All right, let's pause right there. Remember we talked about our reactants, what we start with. In this case, baking soda and vinegar. What we end with was the gas and also water. Carbon dioxide and water. We saw this bubbling, and it also creates water, which you can't really see, okay? But from my experience, I know what is created. So those would be your products. In the law of conservation of mass or matter, the total mass of the reactants must equal the total product. What I start with, I must end with. If I start with 5, how much must I end with? 5. All right, that's the law of conservation of matter or mass.
This means that when a chemical reaction happens, you can't create new atoms. You also can't destroy atoms as they are reacting. The atoms simply rearrange themselves into new substances. Remember our cup of tea from earlier? If we dissolve a sugar cube in tea, the new mass of the tea will equal the mass of the tea plus the mass of the sugar cube. It is easy to see the law in that example, but what about the law of conservation in our bonfire? Originally, many people did not accept the law of conservation of matter. They saw that when you burned an item, it would weigh less after the reaction took place. They did not realize that sometimes mass was lost through oxygen. A bonfire starts with a pile of logs. As the fire burns, the pile of logs will slowly shrink. By the end of the evening, a small pile of ashes is all that will be left. What will happen to the matter that we started with? Will it be destroyed by the fire? Although it may seem as though burning destroyed matter, the same amount exists after the fire as before. Here's why. When wood burns, it combines with oxygen and changes not only to ashes, but also to carbon dioxide and water vapor. These gases float off into the air, leaving behind just the ashes. Suppose we had measured the mass of the wood before it burned, and the mass of the ashes after. And suppose we were able to measure the oxygen used by the fire and the gases produced by the fire. What would we find? The total mass of matter after the fire would be the same as the total mass of matter before the fire. Where did this idea?
All right, let's pause there. So what you start with is what you end with. Okay, I'm going to do another demonstration for you. I'm going to be combining, again, baking soda and vinegar in a closed system. This will be a closed system. All right, now what I'm going to do is to put my vinegar in. I've made a makeshift funnel. And I'm going to put a balloon over the mouth of the bottle so that you can see that the gas is actually being made. Okay? So let's do that. I'm going to wipe this off. Bear with me. And I just made a makeshift funnel here. So if you're at home and you want to get a substance in a narrow mouth bottle, just cut off the top of another bottle and you have a funnel. Okay? That's my makeshift funnel there. I'm going to introduce vinegar, which is also a reactant. So we have baking soda as a reactant, we have vinegar as a reactant. I'm going to combine the two, and before it starts to react, I want to put this balloon over the mouth of it. This would be your closed system. Do you see that the balloon has become inflated? Alright, which gas is being produced in this case? Carbon dioxide. Alright, so the same amount that we start with at the beginning of the reaction is the same that we should end with. I know it looks very suspicious, but just to show you that a gas is produced when you combine those two. That's called a chemical reaction. Okay? Alright, time for your note taking. Remember I said you need pencil and paper? So take your pencil and paper out, and we're going to be taking notes on what the law of conservation of mass is. Can you see that?
Everybody have paper?
Right. Everybody has paper,
Or
your
notebook.
notebook. You are required to take notes. Pick up your book bag, put it underneath your tables for me, please. I do not want to trip on yours. You may be taking your notes as soon as you have your
When this is
utensils
finished.
ready.
Yes.
What is the law of conservation of mass? Law of conservation of mass is the same thing as the law of conservation of matter. Alright, they just changed the word. Mass is the amount of particles that make up the substance. Yes, you're copying that. Oh my God. Get to it. When thinking of the law of conservation of mass, think of a closed system. Remember I showed you what a closed system would be. It means that no gas is escaping. The only way that it does not observe the law of conservation of mass is if a gas escapes. Please remember that. If it happens in an open system, then it does not observe the law of conservation of mass because you will have gas escaping. If it is closed, then you would have the law of conservation of mass being observed, where what you start with is what you end with. Your reactants are equal to your products. Please make a note of that in your notebook. In a chemical equation, which is used to represent a chemical reaction, so when I react baking soda and vinegar, I can write that in a chemical equation. Chemical reactions are written or denoted in chemical equations. The same number of atoms that you start with on the reactant side must be equal to the same number of atoms that are produced in the product side. So our equation has two sides. The left side, right side. Left side, your reactants. Right side, your products. So right up to the point and stop where it says watch Discover Ed video. Great? Copy everything down to that point. Baking soda plus vinegar gives us carbon dioxide plus water. All of this would be considered to be your reactants. What you start with are your reactants. What you end with are your products. Chemical equations are used to denote chemical reactions.
Potential scam.
I'll give you 2 more minutes and then I'll move on. 2 more minutes and then we're moving on. May we move on? Once you're finished copying from this screen, I need you to turn your attention to the whiteboard over here. Okay, that's where our focus is going to be.
We write it now?
Right up to this point. That's your last sentence in your notebook. Number of atoms on each side of the reactant side should equal to the number of atoms on the product side. Your equation has 2 sides. That can come from math, alright? What you start with is what you end with. The right side must be equal to the left side. This is your last statement that you're writing in your notebook. Got it? Let me check if you're following me. If I combine vinegar and baking soda, what do we call these? Reactants. And what I end with would be the product. Alright, so your gas and the water that is created would be the product. And remember, what you start with is what you end with. Right side must equal to the left side. Products must equal to reactants. Alright? Alright, give me your attention over on this side of the room for me, please. Alright? Does anybody recognize this chemical equation? Carbon dioxide plus water equals glucose plus oxygen. Anybody recognize that? Nobody recognize that? If you think of trees, what comes to mind? What reaction takes place? Plants use the sun's energy to make food. It's called photosynthesis. Okay? This is the chemical equation. We have the worded equation at the top and we have our chemical equation at the bottom. On the left side, carbon dioxide and water would represent our reactants. This arrow here, very important, means yield or produce. glucose plus oxygen. We eat that glucose and we use the oxygen to breathe. Here is our chemical equation at the bottom that denotes the worded equation. CO2 is carbon dioxide, that's the formula for carbon dioxide. H2O is water. C6H12O6, that's glucose. And oxygen is O2. So each of these substances have what we call a formula. Okay? The formula for carbon dioxide is CO2. Water, H2O. Glucose, C6H12O6. All of this represents glucose. And oxygen is O6. Now we're going to determine if this equation represents the law of conservation of mass. Okay? Follow me now, don't lose me. Okay? We need to count the number of atoms on either side of the equation. We have the left side, which is the reactant, and we have the right side, which is our product. Let's list the elements on the reactant side. What element is denoted by C? Carbon. Alright, so we have carbon on this side. What element is denoted by O? Oxygen. Okay? And we also have H, which is hydrogen. So we're going to be counting the number of atoms on this side of the equation, the reactant side. Pay attention. This 6 right here is called the coefficient. Please make a note of this. The big number in front of the formula is called the coefficient. Make a note of this. 6 in front of CO2, the big number is called the coefficient. This 2 is called the subscript. Make a note of that as well. Give me your attention over here. Here is your chemical equation for photosynthesis. We have a right side, everything in front of the arrow. We have a left side, everything behind the arrow. Okay? We have numbers that we need to pay attention to in the chemical equation. This big number, what do we say it's called? Coefficient. The small number is called what? Subscript, below. Sub meaning below. It's the small number and it means below. You can only change the coefficient in a chemical equation. You cannot change the subscript. Please make a note of that. Only change coefficient. Do not change subscripts. So you cannot change the subscripts in a chemical equation. They have to remain the same. The only numbers you can change are the big numbers in front of the formula. May I move on? Alright, so let's count the number of atoms now. This coefficient is going to be a multiplier. So anything following it is going to be multiplied by 6 times, if you don't see a number at the base of the chemical symbol, it means 1. We don't write 1 there, we just assume that it's 1 if we don't see a subscript. You're with me? Are you with me? Coefficient is your multiplier. Because we're trying to count the number of atoms on either side. So, let's go. 6 times 1 is what? 6. 6 times 2, 12. Let's go over here. 6 times 2, 12. That's your hydrogen. And 6 times 1. 6 times 1, 6. So we're going to add that to the oxygen. So this is going to be equal to 18. Everybody with me? Let me go again. Coefficient can be changed. It is also your multiplier. Your subscript, you cannot change your subscript. It remains the same. Sub meaning below. It's the small number that is below the formula. To count the number of atoms on either side of the equation, you must multiply subscript by coefficient. Coefficient by subscript. If there is no number or subscript, you automatically assume it is one atom. So let's go again. The coefficient in carbon dioxide is 6. So 6 times 1, 6. The coefficient in oxygen is 2. 6 times 2, 6 times 2, 12. That's for this part. We still have water, which is a reactant on the left side. So we have to count those two. 6 times 2, 12. 6 times 1, 6. So we have to add.
Mr. Paul,
Yes?
Derek Elmore for sign out.
Derek
Other class.
is in the other class.
Okay.
Right, where were we? So we added our 6 oxygen here. Right? You're following me? Coming over on this side now. What do we call this side of the equation? The products. Okay, so we've yielded something. This means yield. We're counting these. We have carbon, oxygen, and hydrogen on this side too. How many carbon? 6. So you're using your subscript to tell you the atoms. How many hydrogen? 12. And let's count our oxygen. We have 6 here plus 6 times 2. So 6 plus 6 times 2 is 12, which is going to give us 18. Does this observe the law of conservation of mass? Do you have the same number of each atom on the right as you have on the left? Hello?
Yes.
Tell me.
Yes.
Yes?
Yes.
How many carbon do you have on the right? How many do you have on the left? 6 on the right, 6 on the left. How many oxygen you have on the right side? Come on. 18. How many oxygen do you have on the left? Really?
18.
18. How many hydrogen do you have on the right?
12.
How many do you have on the left? So if you have the same atoms on the left as you have on the right, what law is that?
Law conservation.
Law of conservation of mass. Thank you very
Speak up,
much
you
for
guys
pointing
know it.
that out.
I've
Alright.
spoken to you guys about not wanting to talk. Speak. When you know this thing, speak.
We're ready? Did you make note of the coefficient and the subscript and what the arrow means? Those are important. The multiplier or the big number is called your coefficient. The small number, which is below the atom, is called your subscript. Sub means below, and it's a small number. What's the rule for subscript? What's the rule? Don't change it. What's the rule for coefficient? You can change it, and it's used to multiply the subscript to get the total number of atoms. You with me? All right, let's go to a video to explain that further. Put your pencils down, give me your attention to the front.
Miss, I hope you don't mind. I got them from morning and I've been forgetting. I'm just going to give it to them.
Go ahead, so let me pull up the video.
Here. I'm not seeing your name.
All right, you get a brain break, so it's going to be pointing out.
You want?
Get your tickets and then we'll go back to work. Okay?
Daniel? Where's the now? I'll find out who's at the gate.
Ready?
You live close to Canard?
Ready? 5, 4, 3, 2, 1. Good? You're still talking. We're going to watch the video to look at how
And it's not
count
because
atoms on the reactant side versus how to count it on the product side. Once we've counted the atoms, if they add up to be the same thing, it observes a law of conservation of mass or matter. Everybody's attention to the front of the room for me, please. Put your pencils down, heads up, face forward. Thank you. Pay
One of the
attention.
seemingly tricky parts of chemistry is learning how to interpret chemical formulas and count the atoms. The first thing you must know is how to identify an element from a formula. Element symbols on the periodic table follow strict rules. If there is only one letter in the symbol, it is capitalized. If there are two letters in the symbol, the first letter is capitalized, and the second one.
What did they say? What's the rule for writing chemical symbols? First letter is always capitalized. If it has two letters, what's the rule?
the first one is
First is capitalized, second is lowercase. Very good. Let me ask you this. If you saw this versus this, which one would be the chemical symbol? Which one would be the formula? Which one is a symbol? Which one is a formula? CO2 is formula. CO is symbol. This symbol is for cobalt. Don't let them trick you. Okay? I trick up a lot of students every year. CO2 is the formula for carbon dioxide. Okay, just pausing you and giving you a little hint. CO, which is capital C, lowercase o, is a symbol for cobalt on the periodic table. Don't let them trick you. All right, continuing.
Lowercase. This helps you identify the elements in a compound like this one. There aren't 3 atoms here just because there are 3 letters. There are only 2, potassium and bromine. In an even more complicated formula, you can still find the elements by carefully looking out for those lowercase letters. They go with the capital letter before them. So we have sodium, hydrogen.
What is C? Carbon. Yes, and what is O?
Carbon and oxygen.
Okay?
But what about the little numbers? The subscripts.
What did we say about subscripts? Remind me. You can't change them. They remain the same and they are always below the symbol. Okay?
Tell you how many of the atom are bonded in the compound. The subscript only applies to the element written just before it. So there are 3 oxygen atoms in this formula. In this formula for glucose, there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. There's even another trick up the chemist's sleeve, coefficients. A coefficient is a number in front of a chemical formula that acts as...
What's the rule for coefficient? You change it to balance the equation, right? And it multiplies what? All the words, the subscript. Very good.
There. Everything after that coefficient is multiplied by the coefficient. So instead of there being 1 sodium atom and 1 chlorine here, there are actually 2 sodiums and 2 chlorine atoms, because there are 2 of the whole.
You remember what we said? If there's no subscript written, what do we assume it to be? 1. Alright, so we would have 2 times 1 gives us 2 sodium, 2 times 1 gives us 2 chlorine.
Chloride compound. The last trick involves chemical formulas with parentheses.
Alright, we'll stop here
When you
because
see-
this does not apply to you. Alright, you think you're comfortable with that?
Yeah.
Alright, good job so far. You've been doing well. Let me give you a practice question. Let's see what you learn. Alright. Label the products and the reactants in the chemical equation. Mg is magnesium, HCl, hydrochloric acid, which you find in your stomach, helps with digestion. Alright? Which side do we have the reactants? Who wants to come and write that in for me? Come for me, please. Let me see if this works. I will have to see. Let me do this. I'll make a copy. Give me 1 second. Don't do anything, okay? I'm just making a copy of the presentation so we can drag and drop. Don't do anything. Can't do it in this batch. You should receive this. No. Okay. Alright, there we go. She's going to do it for us. Drag and drop using my Chromebook. Both. I'm putting you under pressure. Drag the product. Drag the reactant. You're fine. It covered it. Alright, but you're on the right path. Alright, so you're awesome. Was that the product? What do you want to do? Let's correct that. Everybody makes mistakes, okay? I think it's necessary. Let's undo all of that. Alright, let me help you. What should go over here? The reactant. I don't know why it's not happening. So reactants. And over here, we would have our products. I'll just write it in. So reactant on the left, product on the right. You got it? Yes? Now you're still looking like you don't get it. Alright, let's count the atoms. Let's count the atoms. 5, 4, 3, 2, 1. Give me your attention, please, at the back. Young ladies, over here. Alright, here's our chemical equation. CH4 plus 2O2 yields CO2 plus 2H2O. Remember, this arrow means yield. These are our reactants, everything on the left. These are our products, everything on your right. How many carbon atoms do we have on the reactant side?
4.
Huh? 1. There is no coefficient in front of it, so we would say 1. How many hydrogen atoms? 4. Huh?
1.
Hydrogen is here. 4. Your subscript tells you how many of that element is on this side. Okay? How many oxygen? 4. Coefficient times subscript, that's going to give you 4. Let's go over on the product side. How many carbon? 1. How many oxygen? 2. How many hydrogen?
4.
Wait. Hold on. This is hydrogen. 4. Let's get this correct. Good. Hydrogen now. 4. How many oxygen? 2 plus
3. Oh yeah, 4.
2 plus 2? 4. Is it balanced?
No.
Do we have the same number
Yes.
of each atom on the left
Yes.
as we have on the right?
Yes.
What does this observe? What law?
Law of conservation of mass.
Again?
Law of conservation of mass.
Good job. Or matter. Same thing. Alright. I'm going to give you a 2-minute break. You can chit chat, and I'm going to pull up an activity for you to use your Chromebook to work on. Are you having difficulties paying attention, sweetheart? Do you want to get good? Yeah. Let's do what we have to do. Take a seat. 2 minutes. 2 minute break. No, I didn't.
I'll put it back.
I kept the cat.
Who said I got it?
You should look down. You should look down.
Ready.
Alright, make it Chromebook out. Sign in to the quizzes for the Alright, here's your code. Sign in to that page. 5, 4, 3, 2, 1. Get your Chromebooks out for quizzes. Sign in to the quizzes using the code at the front. Quickly and quietly do that for me.
This is very vague. I suck at chemistry.
Alright, 5, 4, 3, 2, 1. I need everybody in their seat. I need you to sign in to the quizzes. Use the code on the screen, 487818. Once everybody has joined, I will start it. It allows for late joining, so there is no excuse for you not to be in it. 128 is your bathroom break. I'll take you then, okay? I heard 128 from the adults.
Well,
That's what I'm going with. It's okay, so I got you.
I'd like to go check.
128. Tell me when it's 128.
And you said I could, so. Brian, what is this one? Was it?
Okay.
Yeah.
Tell me when it's that, alright?
No.
Who am I waiting on?
With 2 Z's. It's Quizlet. No,
Quizzes.
It's Quizlet.
Disease.
Oh, Quizzy. Yeah.
No, this jacket is this. Got it? You're in, Charlie. Alright. Wait. I'm going to start with those who I have. It allows for late joining, so once I've started, if you're not in, go ahead, sign in.
I've been in the class for now.
It's still loading.
Still loading? Who am I waiting on? Just give me a code. Who am I waiting on? 1, who else? 2. Alright, I'm going to start and you two join in afterwards. This is going to take you back to what Mr. Folks taught you, plus what I just taught you, okay? So it's review. Some questions from what Mr. Folks covered, some from what I just covered.
Got this much information like
Get stuck, you have a lifesaver here. Okay? You get stuck, lifesaver. Yay! Alright, so you need a lifesaver. Oh my god. Elements that are malleable, ductile, conductors, those are
Thank you.
Alright. You get stuck, you get one lifesaver. Come out the phone. Put the phone away. We're not doing that right now. Thank you. Oh, God.
Drink.
Big John.
Big Swan.
Big John. I want to go to Newest. Drink Big John. I'm gonna do Big John. I'm trying to figure out how to use me. I'm in second place. Matt, do you still trying to strike me down? Strike me down. That's why I got those chills. Oh no.
What do you think the part that talk about? Your sister wanted to talk
Go on, I hate you in your shoe.
8% and above. If you get less than 8, start again. 8% and above.
I'll end up breaking my elbows. No, I've been getting right the whole time.
Alright, keep going, guys.
I'm dead.
80% and above is expectation. If you get less than 8, start again. Start again, sweetie.
You got one question.
We're bent over. Yeah.
Oh, we don't talk about that.
We're bent over.
We don't talk about that. I'm in 6 now.
Oh my god.
Daniel, what place are you on?
Start over.
Oh my. Hey, guys, where did the take us? Oh my god.
I was about to give you a gift.
You did it to me.
Yo.
Well, if you see a name like your accuracy, if you do that, yeah.
Top 22 good.
Top 22 is crazy.
I just started. I got one question. What's this
I'm
second
going
question?
to punch you. I'm
Ashley, is that the
I apologize.
Sorry. If you got less than 8, start again. That's the expectation. Start again.
I think if you see it,
Are you finished?
it's already Azariah and Ashley.
Sir, whenever you're ready, you can.
They're gonna give me a message.
Alright guys, those who really need to go to the restroom,
Already got in trouble yesterday.
can line up and go.
You got
Nine.
in trouble yesterday because you was
Yeah.
yesterday.
I was here yesterday.
Nine.
She wasn't.
No, I
The
said I
rest
got
of you continue working 80% and above.
I was just
I'm
asking.
done playing this game.
Nat.
I'm not train my book.
No. Because I got beat.
Keep
Did
going.
you just say Arizona? No.
Arizona.
Why'd you put a shield on?
Try again.
You stupid monkey.
Wait.
Dude, the monkey, what are you saying?
That's a good idea.
Guess what? I got a shield up and she can't take it when you get it.
Oh, yes.
What?
If you need a lifesaver.
It took me 3 minutes to find it.
Somebody take my name.